Start with these questions and let me know. Also send the answer on WhatsApp. Okay. Am I audible properly? Ask
Sir, we can't really understand what you're talking.
you can't understand.
Not much. Yeah.
Is it mic or my voice is low?
It's disconnected, or there is a lot of noise reduction in your system.
Okay, just a second. Salman, what about now? Any difference?
Yeah, way better.
And what about the noise? Is it noise?
Sorry, we can't hear.
Sir, are we going to solve the question from the previous class?
Sorry, can you repeat more about it? No, I can't hear you. Can you repeat what did you say?
So so
We heard the voice better. It's Salman, Minati, Khalid, anyone? Khalid, can you hear me now?
We can hear you talking, but we can't actually hear the words you're talking. Like there's a lot of noise reduction in the voice.
It's very feeble. I'm saying it's very low.
Yeah, only some extent of hertz we can listen. We can put it there. Maybe disable noise reduction on Zoom if you're on PC, of course.
Okay, I think now you guys can hear me. You have to solve these questions and send the answer on WhatsApp. Okay. I hope I'm audible now. Yes, Salman, Khalid, tell me.
Somewhat, yeah.
Somewhat, okay, fine. I hope it will get a better. Okay. I hope you guys can do these questions. We have done similar questions in the last class, and I will discuss the third question if you cannot do it. But again, I will tell you how to do this third question also. Yes, Meenakshi, both of those answers are correct. Mohammed Umar, your answer is also correct. Yes, Mohammed Umar, that is also correct. So for the first two questions, we have to just let whatever the number of moles is given, we have to calculate the number of moles as 1 in both of the cases. So number of moles is equal to 1 for the first case. And what is the change in oxidation state? For change in oxidation state, you need to write the, here it is reduction. So you need to write the reduction reaction. That means Zn2 plus will require 2 electrons in order to get zinc. The change in oxidation state is 2, 0. So delta OS, it is equal to 2. So the total charge will be equal to N into delta OS. That is equal to 1 into 2. So this will be equal to 2 Faraday. Now, one thing it's very important that you should remember that whenever you're calculating the charge, always convert this charge to coulomb. So 2F will be equal to 2 into 96500 coulombs. Okay. So 2 into 96500 coulombs will be the answer for both of these cases. Now, for the next question, solution of CuSO4 is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited? Now, mass is equal to what?
ZIT.
ZIT, that is correct. Also, first of all, that means we need to calculate what is the charge. The Q will be equal to I into T. Now, I is equal to 1.5 into time, it is equal to 10 minutes. So 10 minutes, you have to convert it into seconds. So this will be 10 into 60. Calculate this and tell me what will be the answer. 15, 90, 90, 10, 900. 900 coulombs, right? 900 coulombs. Okay. Now, we have CuSO4. What mass of copper it is deposited? So copper 2 plus will take 2 electrons and deposit copper solid. That means 1 mole of copper 2 plus, or rather I should write it like this. 2 Faraday of charge. 2 Faraday of charge gives 1 mole of copper. Okay. 1 mole of copper. That means 2 into 96500 coulombs of charge gives 1 mole of copper. Now I can write 1 coulomb of charge gives 1 upon 2 into 96500 mole of copper. And at last, what you can write? And at last, you can write 900 coulombs of charge gives 900 upon 2 into 96500 moles of copper. Then you can calculate the moles of copper from here, and after that you can convert it into what? You can convert it into grams. That will give you the mass of copper deposited. Calculate the mass of copper and send the answer. First of all, calculate the number of moles. The moles of copper deposited will be equal to 900 upon 2 into 96500 moles. Yes, in the number of moles is correct. Now also calculate the mass of copper. Mole mass of copper will be 3.5 grams per mole. Yes, Farid, that is approximately correct. Yes, Farid, that is correct. Meenakshi, you can further calculate the mass of copper also. Just multiply it by the molar mass of copper.
My answer is fine.
Farid, your answer. Salman.
No, I have sent it photo, right?
Ah, that is correct. That is correct. Also, that is correct. Very good.
Sir,
Yes, Asta.
sir,
Yes,
the
Asta, tell me.
previous class we were doing one question and at the end, like you didn't complete it. So you said you will discuss it today.
Yes, yes, yes. We'll discuss it after. Once you have done these questions, then that question will be a bit easier. Let's say I started with these questions. Okay. Now, fine. For this, the mass of copper deposited, it will be equal to 0.296 grams. Okay. 0.296 grams. Now, right next. This is the question we were discussing in the last class. Okay. I asked you guys to do this question. Asa, did you do this question?
Yes,
Did you
so
try
this
it home?
question only the first part we did and like the second part was left, the mass of copper and zinc. That one.
Mass of copper. Mass of copper and zinc. Okay. So, and what was the charge that we found out for me?
Sir, I don't think so. Everyone solved. You told to solve and then you said that we'll discuss it later.
Acha.
We didn't start the
Okay.
discussion.
So first of all, we'll calculate how long did the current flow. Okay, how long did the current flow? So for that, first of all, number of moles of silver is needed. The number of moles of Ag will be equal to how much? Did you calculate that? Or rather, I can write it just as 1.5 upon. Yes, Mohammed, that is correct. We have to multiply moles of copper from the last question to the molar mass of copper. 1.5 upon 108 grams. 108 moles, right? This will be the number of moles of silver. Now, what reaction should happen? Okay, so this much moles of silver is deposited. The Ag plus is getting converted to 1.5 upon 108 moles of silver. So the charge required will be equal to how much? Number of moles into delta OS. Number of moles is equal to 1.5 upon 108. And delta OS is equal to 1. So this will be 1.5 upon 108 Faraday of charge is required. Now for this Faraday, we need to convert this Faraday to what I said. You have to convert this Faraday to Coulomb. So this will be 1.5 upon 108 into 96500, and the answer will be in terms of Coulomb. Right? So this is the charge required. Now, next thing is, for how long did the current flow? So for that, what is the equation? Q is equal to IT 1.45. Oh, sorry, yeah, correct, 1.45. Thank you, Manashi. Okay. So time will be equal to Q, that is equal to 1.45 upon 108 into 96500. This is the Q divided by I. I is equal to how much? 1.5. Okay, so calculate this, tell me. I think you guys got the time, right? Time, I think many of you guys got somewhere around 890 seconds. Calculate this and tell me what's the answer. फाइव थाउजेंड एटीन नहीं होगा it will be a bit less Asta. See, you're doing some mistake. 1.45 multiplied by 96500. 96500. And this is divided by 108 multiplied by 1.45. No, this will be 893.51 seconds. I can approximate this to 894 seconds. Okay, so this is the answer of the first question, how much time is taking. Next question is, what mass of copper and what mass of zinc were deposited on concerned electrode? So for the deposition of mass, we need charge. What do we need? How much charge is flowing? So how much charge is flowing? Q is equal to how much? Charge, it is equal to 1.45 upon 108 Faraday. Okay, so for the first case, let us talk about copper. Copper deposited. What is the reaction for copper? The reaction for copper is copper 2 plus 2 electron gives you copper. Now from here you can say that if you have 2 Faraday of charge, 2 Faraday of charge gives 1 mole of zinc. 1 Faraday of charge gives 1/2 mole of zinc. And hence we can write how much Faraday do we have? 1.45 upon 108 Faraday of charge gives 1/2 into 1.45 upon 108 moles of zinc. Okay, so once you get the number of moles of zinc, you will multiply it by the molar mass of zinc and get the answer for the mass of zinc that is getting deposited. Write this down. And similarly, do for, the moles of zinc will also be the same. Oh, यहाँ पे हमने copper लिख के zinc कर दिया. Wait a second, guys. Just write this for copper. That would be the number of moles asked, right? Calculate now the mass of copper. Multiply it by the molar mass. Molar mass of copper is given in the question itself. It's 3.5. Yes, Minashi, that is correct. Very good. Astha, it will be a bit greater than that, no? Maybe, अच्छा ठीक है. I mean, but still it will work, no problem. It will work, no problem. And also calculate now the number of moles of zinc and number of moles of zinc that is being deposited and the mass of zinc that is deposited. And actually that is the mass.
Yes.
That is the mass of copper, right?
Yeah.
That is correct. Very good.
So the step till what we say, the number of moles will be same only, no? Only the last step
Exactly.
when we find
Yeah.
the mass will be
Yeah,
different.
correct. Exactly correct. That. And that is the second law of electrolysis. As you can see, it is nothing but mathematical manipulation. And by the virtue of the number of moles of electron that is being used, you can see the number of moles of zinc and copper are going to be same because their Van 't Hoff factor is same, or I can say that their I is same. That means it is also getting 2 plus charge and zinc is also getting 2 plus charge. Okay. That is the reason we are getting the same number of moles. Okay. You calculate and then we are going to write the second law of electrolysis. Okay, answer that would work. That is for zinc ask, right?
Yes, sir.
That would work. Okay, guys, please see. For zinc also, you will get number of moles of zinc deposited would be equal to 1.45 upon 108 into 10. To 1/2 into 65.4. Okay, I hope you all guys got up till here. This will be the complete mass, not moles. Okay, now write the second law of electrolysis. Yes, Mirashi, that is correct. Write with me. When same charge is passing, when same charge is passing through different electrolytes, then the mass deposited at electrode is directly proportional to equivalent weight.
Okay. After this, can you please copy some definitions? Can you please copy this?
Sir, can you show the second law definition?
Okay, just a second. How is your health, Mohammed Umar? Any better?
What, sir?
How is your health?
I can say 2% better.
Health. तबीयत कैसी है आपकी? 2%.
Yes, only 2% better.
2% better. How did you quantify that?
Huh?
How did you quantify that? 2% है या 3% है?
No, I'm just making a guess, you know.
You are making a guess. Okay. I hope it gets better. आपने
It
message
will.
नहीं किया लेकिन I told you to message me.
So I'm busy actually. I made up my mind to text you, but I got busy with other matters.
हाँ अच्छा okay fine.
I will text you when I'm free.
हाँ sure do that.